Hi everybody, it's Mrs. Cassell, and this is Friday quiz number 3, constant velocity. Right? So first thing it's asking us for here is to find the algebraic solution to these. We're just solving things. We want to solve this equation for t. All right, I'm going to get t in my numerator, multiply both sides, divide both sides by v. So that means I'm going to end up with t equals displacement, time equals displacement, divided by velocity, which is this one right here. I'm going to solve v equals delta x over t, velocity equals displacement over time, for displacement. So that one's easy. I'm going to multiply both sides by t. That leaves me with displacement equals velocity times time. This one, velocity equals displacement divided by time. I want to solve it for final position. So this one is relying on the fact that this is actually final position minus initial position divided by time. Multiply both sides by time, cancels that out. I've got v times t equals final position minus initial position. So I'm going to add initial position to both sides, which cancels that out. So I've got final position equals velocity times time plus, I put an I in there, oops, my bad. Plus initial position, which is this one. This last one, velocity is equal to displacement divided by time. I want to solve for initial position. So basically I've got the same math, so I'm going to skip a step here. Velocity times time is equal to final position minus initial position. This one I've got a negative sign to contend with, right? So I am going to move it over to the other side just so that I get everything into the positive. So I have over here initial position plus velocity times time equals final position. Now I'm going to subtract that velocity times time from both sides. Initial position equals final position minus velocity times time, which is this one. Okay, so next we've got a story problem here. This is a great problem. Billy Bob Bow is working on his fast pitch. One fateful game, he throws the pitch of his life. The ball streaks the 18.4 meters from the pitching mound to home plate and is caught with a resounding smack, heard 0.53 seconds after the ball leaves Billy Bob Bow's hands. So we've got that this is the displacement of the pitch, right? The pitch is traveling at some velocity, and then smack, a sound comes back to where Billy Bob Bow was standing over here, right? So we've got two different parts to our motion here. Both of these, the distance is 18.44 meters, but this time that's right here, this is the total time. This is the time for the pitch and the smack, which are both traveling at different speeds. So we need to analyze these two motions separately. All right, so part 5, it asks us if the speed of sound is 340 meters per second, what's the speed of the pitch? Okay, so let's write down a few things we know. Speed of sound, 340 meters per second. The total time, 0.53 seconds. The displacement, and remember I'm going to treat these separately. So my displacement isn't 0. I really have two different motions that I'm analyzing. So I could just as well have written distance, but I'm going to keep our symbology consistent here. Oh, whoa, 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 that's meters. Oh my goodness, not seconds. What was I thinking? And then I don't know what the speed of the pitch is. Let's clean this up just a little bit. Might as well do a nice job for you guys because you deserve it. That's what I'm trying to find. Okay, so first thing I'm going to do is I'm going to figure out what the time for the pitch is, because I know I need to subtract that from my total time in order to find out how much time it took for the ball to fly the 18.44 meters. Okay. Well, I know that velocity is equal to a displacement over time, so I'm going to solve this for time. time times velocity equals displacement. Divide both sides by v. So time is equal to velocity time. Oh, with displacement divided by velocity. I can read my own writing. So now I can just plug in my numbers here. The time for the pitch is going to be 18.44 meters divided by 340 meters per second. If I check my units, the meters are going to cancel out and leave me with just seconds. So let's go ahead and do that in my calculator now. 18.44 divided by 340. That's a teeny number. But I want you to think about how fast sound is. Does it make sense that it would be a teeny tiny number? It does. All right, next, let's figure out, we've got our total time. It's going to be the time for the pitch. Oh, I even wrote that up here. Oh, my bad. Hey, that's the time for the sound. This is that moment where I contemplate, should I read you the video? And I'm going to choose no. I'm going to assume that if you're still watching at this point, you're an intelligent human being, and you can see that I made a typo. The time for the sound plus the time for the pitch. So I have figured out what this number is, and I know what this number is. So I know that my total time minus the time for the sound is going to equal my time for the pitch. So I've got 0.53 seconds is my total minus 0.054, that's the time for my sound. And when I do those in my calculator, 0.53 minus 0.054, get 0.476 seconds. That's the time for the pitch, labeled correctly this time. And my last step now is to calculate the speed of the pitch. I know what my displacement is. It's 18.44 meters divided by 0.476 seconds. I use my calculator to do my math. 0.476. 38.74 meters per second. Now our last problem here is to convert the speed of the pitch to miles per hour. I love doing this. I find this very relaxing. 0.74 meters per second. So they tell me that 1 mile is equal to 1,609.34 meters. These two things are equal, so I'm just multiplying this by 1, right? 1 mile and 1,600 meters are equal. So these are equivalent. So this is 1 divided by 1 is basically what this is, right? And so I can multiply anything by 1 as many times as I want. That's how we're doing these unit transformations. We're finding ratios between different units that are equivalent. So we're mathematically just multiplying by 1. Next, I've got seconds. There's 3,600 seconds in 1 hour. Or you can think about, I could break it out into, let's do all the components. Let's do it. Let's do all of it. There are 60 seconds in 1 minute. There are 60 minutes in 1 hour. So that's my entire math problem right there. You'll notice everything right here is this zigzag of a unit on the top and a unit on the bottom. I've got seconds in the bottom over here, so I put seconds in the top over here. I've got minutes in the bottom, so I need minutes in the top. The idea is that way the units will cancel as I go through this computation, leaving me with just miles on the top and hours on the bottom, miles per hour. All right, so let's go ahead and do it on my calculator here. I have like no room on my desk. Okay, here we go. 38.74 divided by 1,609 609.34 times 60 times 60. Just multiply my fractions straight across. This is a fast pitch. It is the pitch of this young man's life. 86.66 miles per hour. You could round it differently if you want. So there we go. That's your solution for this Friday quiz number 3.